Hello guys, welcome to Refer UX. Myself Nimesh. Today, let's see how to implement a secure office network using GNS3. As you know, nowadays environment security has become a vital area due to lot of attacks uh, happening towards office networks. Hence, communication among the mm, branch officers is also become a vital area. Today, let's see this given problem for a common scenario where an organization called ABC, random organization, has two branch officers other than HQ. Branch officers denoted as O1 and O2, and this particular organization has below mentioned security requirements where each branch should have a minimum of two development machines and marketing machine, and uh, between office 1 and office 2, except by development machines, marketing machines should not be able to communicate due to security reasons of their own. And also uh, for in a given branch, both marketing machine and development machine should not be communicated. That is their own internal communication issues. And also we have to implement security mechanisms in order to secure entire communication between office 1 and office 2. And also we are supposed to uh, prove the workability of the solution using Wireshark traces and other necessary modes like logs. We can see the access control, packet captures, and ping traces to show these stuffs. And this is the network diagram that we are going to implement using GNS3, and we will have mainly 4 VLANs, 2 VLANs in Office 1 and 2 other VLANs in Office 2, and we have 10 10.10.000 network in the Office 1 and in the private network for their security, and 20.000/24 network in the Office 2 private network, and other given IP addresses in the router interfaces. And with this, let's start the implementation of this secure network using GNS3. Okay, first let's create the network as per the question we have. We have R1, router 1, and we have router 2, and we have router 3. And these three will represent the respective officers and headquarters, and let's say branch 1 and branch 2. And I'll quickly add the two switches here. This is for the branch 1, office 1, and this is for the office 2. And then I'll quickly add the relevant PCs, because each branch has its own development machines and marketing machines as per the question. And this is the PC4, PC5, and PC4 and 5 are both development machines, and the last one, the marketing machine. Now I will first enable, I'll now connect them. First I'll connect the routers where this is, let's say, 01 with 00 here, and this is CO1 with here 01, and here 00 with this G00, and this is 00 with again G00, and here G01 with PC1, G02 with PC2, and G03 with PC03, and here also 01 with this, 02 with this, and 03 with this. And the wiring part also done. Well, we can quickly go to the configurations, but before that, let me do some clarification so that I'll make some space for you to understand this properly, and that you can see the interfaces clearly. And get it here, and here, and here. All right, cool. And here all the Ethernets, no need to worry about that. E0, and this is P0, and 01, 03, and 02, and here also Ethernet 0, right? Here also 0. Cool. Now we want to have a clear idea that this would be our let's say HQ, and this would be our office 1, route office 1R, and I would say this is office 2R, and this would be the relevant offices switches 1 and switch 2, right? So uh, and also the next important thing is the relevant IP addresses. What I'm going to do is I will name this interface as 216.21.5.1/26, and I will get this as 16.21.5.2/26, and here I would take 216.21.5.65.5/26, and I'll put it here so that you can easily see. And the final one would be, I will duplicate of this and this one, and this one would be 66 and 26. Okay, and this one would be 65. Okay, I'll make it as 65. Cool. So we have 65, 16, 65.2. Oops, I think I made a mistake. It should be 5.2, 5.2. All right, 5.2, 5.1. Okay, I'll make it a bit larger. 5.2, 5.1, and 5.55 and 5.66. So those are the two interfaces, and that we will be mainly using for the IPsec tunnel. Actually, these are the peer IPs and the main branch IPs. And here we will put this to development machine into actually before that I want we will have this site in the 10.10 private network, and here we will have 20 private network. All right, so whatever the traffic network would be, internal network would be 10 network or 20 network. And also these two IPs, these two machines we will put into 10 VLAN 10, and the VLAN would be VLAN 10, and this one will get into VLAN 20. Right, cool. And here also we will get this one as 20 VLAN and 20 network and 30 VLAN. All right, you can have your own. There are no need. What I'm going to do is my own network, so I'll make it as 40 here. I'll make it 40. Cool. So now we have two VLANs here, and 3 sites, 2 branches. So we want to have a second network over these 2 branches mainly, and so I'm going to implement IPsec over here. But first I'll show you the connectivity between these 2 branches without security, IPsec over the encryption. And I'll enable the encryption, then we'll see the traffic. Then I'll enable the VLANing in order to separate communication in individual branches. And also I'll then finally I'll add some access lists in order to add some rules to prevent communication among the given sections. So before moving, so this is the network. So what I'm going to do is I will run the simulation, network, and seems everything is working properly. And I'll try to get some spaces, more space here. Okay, then I'll enable the configure terminals in order to do the configurations. As you can see, all PCs configuration terminals are opened, and routers, and finally switches. All right, so let's and let the routers and switches to be boot. We will start the configurations. First configuration, I'll add the IPs. First IP, first route, first PC IP 10.10.02/24, and the gateway would be this. All right, and I'll especially the save command so that it will be saved. Second one would be 10.10.3/24, and this will be saved. Third PC, and the default gateway would be that is under VLAN 20, and save. Next mode of PC4 20.30.02/24, and this is the default gateway, and I will save it. And I'll go to PC5. There again I select one, and I will save this. PC IP 40 VLAN, and cool. Then we'll move on to the routers, and since routers are booted up. And let's go to configuration terminal and interface, fast Ethernet. Well, before that, all right, let's say we'll go with that. We'll go to R1 and interface, fast Ethernet. Well, 0/0 initially, and I will make it no shutdown, and then I'll go to interface, fast Ethernet 0/1, and IP address would be 216.21.5.1. This is the one I /26, and 21.5.1, and shut down. Then what I will do is I will enable routing among the networks reachability, so that I say router IP as is number 1, network would be network. And with this I will write the configurations, and I will router 2, which is the HQ router, and what I'm going to do is configuration terminal interface. Yeah, 01 only I have added. Yes, cool. 5.1. Yes, cool. R2, the initial one will be F00. Interface pass it as 0. Then I will add the IP address, which is at the IP address is 216.21.5.2.255.255.255.255.19. Now shut down. Cool. Then I'll go to next. Interface fast Ethernet 0/1, and the IP address would be 216.21.5.65 and shut down. And the next interface fast Ethernet. Wait, 0 I configured, 01 configured, so now everything is done. Then what I'm going to do is I will enable routing route EIGRP1, and the network would be right. I write everything so that configuration will be there. And thirdly, router 3. I will do what I'm going to do is I'll go there and I'll get open configuration terminal, and the first one would be 00 interface fast Ethernet 0/0 and just normal shut. Then I'll go in interface fast Ethernet 0/1. IP address would be 21.5.66 and now shut down, and then route EIGRP1 network would be 6. And also very importantly, right configuration. It seems now let's see whether we can ping to the among the right. Before that, I'll take the ping from R1 to R3, where what we can do is we will ping it's 216.21.5.66. Wow, cool. We have full reachability from R1 to R3. Very good. Now what I'm going to let's see the routers, whether they have setups, whether they have got into configurations, they have booted properly. And meanwhile, let's try to ping to standard.n. And so we got 3 actually, and pinging nicely, and that is the same development machine. And the 10.0.0.2, the other VLAN. Well, host is not reachable. Wait, right. All right, cool. You know why? Because these two are in different VLANs, which is correctly we haven't implemented any VLAN inter-VLAN routing here. That is why it is unreachable. That's okay. That's cool. We'll enable that. And Secondly, I want to show you this is the initial configuration, and then what we're going to do is the default gateway should be fixed to 10.1. To do that, what I'm going to do is now initial configuration of the routers has been finished. Then what I'm going to do is um, I will enable VLAN, so inter VLAN communication, so that this PCs would be able to communicate each other without any issue. All right, cool. So we'll do it. So first we'll go to router 1 and enable, then we will configuration terminal, then the VLAN, the first VLAN will be VLAN 10, and the name of the VLAN would be VLAN 10. Right, exit. The next VLAN is VLAN 20. Name of the VLAN would be VLAN 20, and I'll say show VLAN. So we have two VLANs here. Cool. And the next one would be I will go to I will add still you can see no port has been assigned here. So I will do the same VLAN creation here. Okay, before that I will add the ports here. For example, I'll go to configuration terminal, switch, select the interface Ethernet 0/1, switch port, mode access here, and switch port access VLAN. PC1 would be VLAN 10. So exit, interface, giga/2, switch port, mode access, and switch port access VLAN 10. So both development machine PC1 and PC2 are now accessing via VLAN 10. And again, I'm going to interface Giga Ethernet 0/3 and switch port mode access and the switch port access VLAN 20. Cool. And exit. And that's one final thing, that is defining trunk communication between G00 to F00. To do that, what we are doing is I'll go to interface giga interface giga net 0/0 and switch port mode trunk. Obviously we get this error because it has been auto. We have to manually set it is .1q tunneling mode is there. Switch mode trunk encapsulation would be .1q. Then again, if you run this mod trunk command, it's working. Cool. We have done the switching configuration part. Now it's up to we'll go to router 1, and router 1 we will go to configuration. I'll first show IP interface brief. You can see that only 0/1 is configured, and this is up but not assigned one. That is because we are using this as a router on stick configuration. You can see that video to get more information. Also regarding VLAN configurations, you can see my other basic VLAN basics video, so that you have those information there. What I'm going to do is now I will create sub-interfaces, two sub-interfaces to make communication available between VLAN 10 and VLAN 20. To do that, what I'm going to interface, pass it as 0/1. We have 0/10. All right, now we have sub-interface encapsulation .1 and we have set the VLAN number, 10. Then we have set an IP address. It should be the IP address of the VLAN should be VLAN 20 IP address is 10.10.0.1 and 255.255.255.0 because it is slash 24 network, and it's obviously not shut down because it is already 0 later is not shut down. So what I'm exiting. Then I'll again go to interface fast Ethernet 0/0.20 for the VLAN 20. Now we are in the sub interface. Now encapsulation.1 queue, and the VLAN would be 20. IP address. Oops. Let's say IPC add. Okay, right, cool. You don't need to worry about that. We'll say IP address dot 20.1 and cool. Seems everything is up. We will run the configuration, we'll build it, and if I say show the interface brief, and you can see nicely two sub interfaces there. And if now we try to ping to second interface, you can see that we can now successfully ping to the marketing machine through the development machine, so which is a good thing. Now let's see whether we have reachability towards gateway. The gateway one would be 5.1. Let's say that we have reachability to 216. Yes, we have reachability. Now let's see that we have reachability towards here, 3.66. Yes, we have reachability up to that point. Now we'll configure this part as well so that we can go up to these computers as well. Well, to do that, what we can do is we'll go to switch 2, and again we will create configuration terminal. First, VLAN. What is that? VLAN 30 and VLAN 30 and exit. Then VLAN 40 and VLAN 40. Right, exit, and I'll say show VLAN. And see, we have two VLANs, VLAN 30 and 40 created, but no ports have been assigned. Now let's assign the ports there. To do that, again, I configuration terminal. Alright, cool. Then I'll go to interface guide 0/1, and again the switch port mode access switch port access VLAN 30. There is second development office 2 development machine 1. Again exit, and you can say 02 here, and again switch port mode access, then switch port access VLAN 30, switch port access VLAN 30. So again I'm exiting this, and again I go to VLAN interface 0/3. So I'm using up arrow to make it more fast. So again I'll make it into switch port mode access, and the switch port VLAN 40. So everything is done, and that's one more thing, that is configuration tunnel over here. To do that, what I'm going to do is interface guidance 0, switch port, mod, trunk, and so also we have to configure it manually. To do that, what we are going to do is um, switch port, trunk, encapsulation, one queue. Then again, the early commands working now properly. So switch site configuration is done. So I'm writing this to. So let's see, and yeah, writing the configuration here. And also, if I'm not mistaken, I have to write the configuration. So I'm writing right building configuration tool, and while they are building the configuration, okay, they have write it successfully. You got to write a successful message, and till they are doing it, we are now in the router 3. So router 3, we have to go to I'll first say show IP interface brief. You can see only 01 is configured. Now we are going to create sub interfaces on that, and on sub interfaces on 00 here, likewise here also 00. So we are going to create interface, sorry, configuration terminal, and interface pass it as 0/0.30, and the IP address would be, and sorry, and the then encapsulation one q 30, and the IP address would be 20.30.0.1. Let me check whether I have given that both here. Start right cool. We have sub interface 8.1.1 did in separation .1 q, and here also sub interface 2 and in separation 20. Then the IP address code. We are good to go. And here again, I'll exit interface pass Ethernet 0/0.40, and we are submitting an encapsulation .1 q, and the IP address would be and writing the configuration so that nothing will be erased after that. So it seems now building configuration is done. I'll show the running IP interface brief. Now you can see two sub interfaces here, and now what we can do is we will now try to ping again to, you can see easily ping to 66, and then what we do is we will go to the other NPC, that is in the body, right, body dot 2, and it seems that we have good connectivity between the Office 1 and Office 2 marketing machines from development machine to marketing machine, and from development machine to development machine, and also let's say from marketing machine to marketing machine, and we have good connectivity there. And so now we have implemented full connectivity here, and so this next part would be implementing IPsec, and I will add that part. I will now implement that part. Seems this video getting a bit time consuming. That's okay. Now I will enable the what do you call IPsec, but before that I'll show you. So now through to this here, I'll show you the packet transfer through Wireshark, and you can see that nothing is encrypted. If I ping, what will happen is wait until it is loading. Right, now I will ping, and you can see that nothing is encrypted. All ICMP source and destinations are showing, so this is not a secure communication. So I'm going to now implement a secure communication between R1 and R2 officers, so that everything would be encrypted, and ESP packets would be there. So to do that, first I'll go to R1 and I'll go to configuration terminal, and I'll go to crypto, ISACamp, enable, and again crypto, ISACamp, policy 1. Then I'll show you what are the available policies. These are the things I want to configure. So first in our encryption mechanism would be AES, and there are a couple of things. I'll select AES, and also the bit level I'll select 128. Then I'll go to authentication, and here there are few. I'll select the pre-share, and I'll get the group, and this is the Fidelman group, and this is about 750. This is 1025, this is 1500. The better one would be 1024, the second one. I'll go to and the hashing mechanism. There are a couple of MD5 and SHA. The SHA would be better, so I'll put SHA. The next, I'll go to crypto. I'll set the key, the secure key. I'll select crypto ISACamp key, and I want to make it encrypted, so 6, and I'll select the password for the sake of here doing ABC123, one of the very easiest password. Don't put this. This is just for the simulation purpose, so I put education purpose as ABC123, and the address would be any address. Right, cool. Now we go to crypto IPSEC. Now I'm creating, now initially I created the authentication part. Now I'm creating the data tunnel, and there I'm saying transform set. I have set the transport name, transport set name, then I'll set our set, and then I have to select the ESP mechanism. I'm selecting AES1, so ESP AES, and the bit level would be default. I'll say 128, and I'll say the header, and this hashing mechanism. So again ESP, and which is sharp HMAC algorithm, and it is done. Now the next one would be creating access control list in order to command to the tunnel that which network that we need our interested coming onto into our interested traffic. To do that, I'm saying IP access list extended, and obviously number would be above 100. So in this case, I use 100, of course. Right, I use 100, and this permit any traffic relevant to IP, and my network would be 10 network to 20 network. So what I'm going to do is here 10.10.0, and I want anything, and anything from first 3 octants, and anything coming under 10 dot something something, I will allow it, and sorry, anything coming under, yes, 10.0 10.00 something I will allow. I don't mind the final bit, but first 3 octets should be 10.000. In this case, it will consider in a way that any traffic which are coming from 0 0. So exactly should be there. So let's see, instead of doing that, if we say anything coming from 10, it should allow something like that. That would be better. So there could be 10.20, and there will be an ambiguity then. So anything coming from 10 would be allowed from here. And to so I don't mind here any other things. So my interrupted traffic would be started from 10 and ending from 20. That is my interrupted traffic. Then I'll go to crypto map. I'll create our map. Then the policy would be 1, and it should be IPSEC-VPN. Then it says that until we match relevant peer and addresses, it won't work. So we'll match. First match the address, it is our access control list. Then we'll set the peer, remote peer. Our remote peer would be what is our remote peer? It is 10.5.66 is our remote peer. It's 216.1.5.66. All right, let's see that. 21.5.66. 21.5.64. And set transform set is, that is our data traffic, is our set, and then one just configuration, that is for the interface, pass Ethernet 0/1. That is the interface that we are going to apply this policy. So crypto map our map. Now, as you can see, you get a message that there is a camp is on full. Now I'll write the configuration. Now we'll go to router number 3. Then we will start the same configuration. I'll do it fast this time since we have done explanation in the previous one. Crypto enable, and again crypto policy 1, encryption AES 1 to 8, authentication pre-share group 2, and hashing would be SHA, and the key would be encrypted, and the address would be, and crypto IPsec transform set, our set, and ESP AES 1 to 8, ESP SHA, and then IG access is extended 100, and then what I'm going to is extended 100, and let's check if it's recording. Yes, it is recording. 100, and permit IP, it should be right. right? So there's something here. See, 0 0 0 is 0 1 2 3. So one part should be omitted here, and here also 10 0 0 10 0 0 0. So 0 1 2 3. It is done. And one more thing, crypto map. Our map policy is one. IPSEC camp, and I match the address 100. Set here, remote here would be 5.1. So 21.5.1. Right, cool. Then set transform set. It is our set for the data, and just one final configuration, interface transit and 0/1. It is where we are going to add our well, seems now it is on, and I'll write the configuration just to check whether we have configured properly. We'll see a ping message whether it is receiving timeout, ping timeout, ping timeout. Oh, very good. We have a connectivity. We have a connectivity. Then what we are going to do is we will check whether our communication is encrypted. So this is the first part, the first link, which is R1 to R3, and I will enable the Wireshark, and it's loading. Then we will see after the tunnel, will there be any traffic encapsulation happen. Please wait, it is initializing. Okay, it's starting. Cool. And a couple of EIGRP messages are there, and also start capturing. Okay, and still starting. Loading modules. Wait, and let's see whether we have a proper match there. And cool. And yes, we have again hello messages, and we'll see now ping. All right, I'm pinging from PC1 to marketing machine of the other side, and you can see in the router 2 to router 3 fast Ethernet, that is in this segment I have captured, and you can see everything is ESP, which means ESP in the sense encapsulation security payload, and you can see that the protocol is next protocol is 50, which is IPsec is properly implemented, and you can see no ping messages. But in the other side you can see from PC switch to router 3 to switch, this is the other side. You can see all these ICMP messages from 10.00 to 20. That is the PC1 in development machine 1 in the office 1 to marketing machine of the office 2. This is purely unencrypted. You can see that you can see we don't have any ESP. We can see that it is VLAN is enabled. .1 queue is there, and just you can simply ICMP and the payload you can simply see here. However, here we can see we can't see such information. You can simply see in the ESP. We can see that 5.1 to 5.63 is the router 1 and router 3 interfaces only, so we can't see intermediate traffic. This is called implementing security through the network. So this is it. And now we have configured the IPsec, and the final part is now it's a very lengthy one. Now that's okay, we have come to the final part. the final part. Okay, I'll now stop this, and those are the proofs that you can show to anyone that okay, my network is working as promised. All right, cool. Stop. I'll stop the Wireshark. All right, cool. The final one is I don't want these VLAN 10 to be communicated with VLAN 20. Um, Obviously, one option is you can remove this inter-VLAN communication there. That is one option. However, since we have initially, if we want to show that it is working, the the the, the one since in order since those two are in two different VLANs, we were to enable communication over the net, so that we have to implement through the sub interfaces. So what we can do, we can add an access control list in order to prevent them communicating each other. Secondly, we want to enable what you call the marketing machines of Office 1 to be communicated with marketing machines of Office 2. However, marketing machines should be of both parties, should be able to access development machines respectively. You got the point? It is available in the slide number initial description of this video. Please go through them. And I'm going to implement those access control lists now. Let's see how we can do it. First, what I'm going to do is I'll go to route number 1, and then what I'm going to do is I'll go to a configuration terminal, and I will create access list. Well, I'll create an access list number 150 for this case, and I'll say deny. I want to deny what you want to deny: accessing anything, any IP protocol from 10 this particular network 10.10. 0.0 that I don't mind anything here to 10.20.0.0, and I don't mind this is my access list. Also, I want to allow for this permit IP of any other. Right. Now we are going to interface fast Ethernet. We'll put to sub interface, and I don't want them to communicate with that. So the for the what do you call interface perspective, it sees as coming some traffic coming in. So interface this one, and IP access group, and it is 150. Direction would be in. So in, it is whether it is happening. All right, cool. Now let's see whether we can do it. We will now first first we can see whether we can go reach to other network. Yes, we can reach to the Office 2, no problem. Office 2 both marketing and development machines. We have from the development machine of the Office 1, we have no issue. Secondly, we see whether we can access to our own development machines. Very good, we can do it. And let's see whether we can achieve our own marketing machine. Voila, the access list has been implemented. Communication administrator prohibited, because now the development machines cannot access marketing machines, or any other way. Marketing machine also is not able to access let's say to being marketing machines cannot access the what do you call development machines code. And second thing is we'll do the same thing in the router 3 as well. Configuration term access list. Let's say 150. And deny IP anything from 30 going to from this to again we have to allow, right? Allow any. Then we have to go to interface dot 30 and IP access group 150, and the direction would be, and as you can see I want to first I haven't put right here, I will make it writable, and here also I will make right. Now I'll check whether PC4 this is a development machine can ping its own development machine pool. Development machine can ping to other side development machines. Yes, development machine could ping other side marketing machine. Yes, and however development machine cannot ping other side, its own marketing machine, and likewise we cannot ping marketing machine, also cannot ping development machines there. To verify that, what you can do is so you can show access list 150. You can see how many drops happen, permits happen. All right, so this is the proof that you can show to anyone that my access is working. Now the final one, but still marketing machine of Office 1 can ping to marketing machine of Office 2. This also should be prohibited. So what we can do is we can go to R1. Again, we can say access list list. We can go to configuration terminal first, and access list, let's say 160. Deny IP of 10.20.0.0, accessing 20.40.0.0. Yes, it's here. And I believe now it's okay. And also we have to say permit IP of any. Now we'll go to interface class 0/0.20 sub interface and IP access group. This is 160, and direction would be from marketing to other marketing, and let's say so this is also again in, no? In. So if in, it decides. And let's see whether we can do it. We'll try to write this. Okay. And I'll try to ping from PC3 to its own. Right, we can ping to its own development machine of Office 1. Sorry, we can't. We can't now. We have put up a thing, no? But we should be able to ping to other site. Yes, we can ping other sites development machines, but our own development machines, we our marketing people or our people cannot do. That is the competition. And however, other site marketing also should not be able to access. Yes, and our access list is working. Same as here. If other site marketing try to access our site marketing, it is not going to work. Yes. However, if they try to access our own development machine, they can. They also cannot access their own development machines. Yes, they cannot. So this is the complete demonstration of the question that we got of implementing network security mechanisms like IPSEC, VLAN, and access control list in a given Office network as per the question slide in the first part of the video. And thank you very much. In this tutorial, we demonstrated how to implement a secure Office network with the given criteria of internal security using VLANs and over the physical security using IPsec, and also some role-based protection using access control lists in the given as per the given scenario. And also we explain the workability of the solution using Wireshark tracers, pin tracers, ACL packet captures to show the efficiency or other workability of the solution. I hope you have learned something out of this video. If you learned something, please do like and share. If you want to know about future such videos soon when you release, please subscribe to us. Till you meet again, have a nice time.